So guys, welcome to our video. We are the fourth group of S division, and our topic for the COAA assignment is cache memory. So in this video, we will understand what is cache memory in computers and laptop. So in this video, we will see what is the importance of this cache memory, what is the typical size of this cache memory, and what are the different levels of cache memory that we find inside the computers. So, before we understand this cache memory, let's see different kind of memory that we see inside our computers. So, the first kind of memory that we find inside our computer is the non-volatile kind of memory, like a hard disk drive. So, this hard disk drive contains mechanically rotating fast disk, which is also known as platters. And if you see any commercially available hard disk drive, the typical rotating speed of the disk is either 5400 or 7200 RPM. So, as this hard disk drive contains a mechanically rotating part, so in the terms of the speed, they are quite slow. So, the typical read or write speed that you get with this hard disk drive is in the range of 80 to 150 Mbps. But if you see the clock speed of the CPU, it is in the range of 1 GHz up to the 4 GHz. So, even though the processor is capable of accepting a data much higher speed, but it can't get the data through this hard disk drive at the same rate. So, I would now like to conclude this.
And that is where the second kind of memory comes into the picture, that is random access memory. Now, this random access memory is faster compared to the hard disk drive. So, this RAM can provide data to CPU at much faster rate compared to hard disk drive, but still it is slower than the clock speed of CPU. So the typical speed of RAM in the range of 400 MHz to 800 MHz. Still it is slower than the clock speed of CPU. But if you see the newer generation of RAM like DDR3, DDR4, then they can operate at much faster rate like 1600 megahertz to 2100 megahertz. So now if you see the speed of RAM, they are comparable to speed of CPU. Now you may say that the newer version of RAM can supply data to CPU at the rate at which they want, but answer is no. So the modern day processor which we are using is not single core processor, but they are multi core processor. So this processor could be either dual core, quad core, or maybe even octa core. So if all the cores are asking for data at same time, then this RAM can't be able to deliver the data to all the core at the same time, and that is where this cache memory comes into the picture. So this cache memory is faster among all the memory. So this cache memory is also random access memory, but it is a kind of special kind of RAM which is known as static RAM. So unlike the dynamic RAM which we find inside the normal RAM, this static RAM is quite faster, and the typical size of this cache memory is in the range of kilobytes to few megabytes. So the data which is frequently required by CPU can be supplied by this cache memory. So generally all instruction and data which is required by CPU are stored in the cache memory. So now let's see the different level of this cache memory.
The first level of a cache memory is known as level 1 cache or L1 cache. So in this L1 cache, tiny amounts of memory is integrated inside the CPU itself, and all the cores inside CPU have the individual level 1 cache. So as this level 1 cache integrated inside the CPU, so they can operate at the same speed of the CPU. And this is the reason level 1 cache is fastest among all cache. Now the typical memory size of this level 1 cache is 2 KB up to the 64 KB. Now inside this level 1 cache, there are two kind of cache. The one is instruction cache and the second is data cache. The instruction cache stores all instructions which are required by the CPU, and the data cache stores the data which are required by the CPU.
Now let's see the second level of cache. So this cache is also known as either level 2 cache or L2 cache. Now this level 2 cache could be either inside the CPU or it could be outside the CPU. Now this level 2 cache could be separate for all the cores or shared between all cores of the CPU. So if the level 2 cache is outside the CPU, then it is connected with a very high speed bus with CPU. So the memory size of level 2 cache is in the range of 256 KB to 512 KB, but in terms of speed they are slower than L1 cache. Now the third kind of cache is known as L3 cache. So all the processors do not have this L3 cache, but some higher end processors have this L3 cache. And this level 3 cache is used to enhance the performance of the level 1 and level 2 cache. So now this level 3 cache is shared among all cores and this is outside the CPU. The memory size of this level 3 cache is in the range of 1 MB to 8 MB for high-end processor, but it is slower than L1 and L2 cache, but still it is faster than random access memory or RAM.
So now let's see the process flow when CPU needs some data. So whenever CPU needs some data, first of all, it will look inside the L1 cache. So if it doesn't find the data inside the L1 cache, then it will look inside the L2 cache. If the data is not inside the L2 cache, it will look inside the L3 cache. So if CPU finds the data inside the cache memory, then it is known as a cache hit. But if the data is unavailable inside the cache, then it is known as cache miss. Suppose if data is unavailable in the L3 cache, the CPU will look inside the random access memory or RAM, and still, if it doesn't find any data inside the RAM, then it will get that data from the hard disk drive. So when you're booting up your computer for the very first time, or if you're opening some application for the very first time, then the data will not be available in either cache memory or in RAM. So at that time, CPU will receive the data from the hard disk, but once the application is launched, and then if it requires some data, the CPU will get the data from either RAM or cache memory. Now, you may ask that if the cache memory is so fast, then why is the size of this cache memory only in megabytes? So the reason for this is that this cache memory is much costlier than other memories. And that is the reason you find only a few megabytes of cache memory inside the CPU. So whenever you are buying some desktop or laptop for yourself, don't just look at the random access memory, but also look how much cache memory its CPU has, because this cache memory decides the overall performance of the processor, and the same thing is applicable for the smartphone processors as well. So I hope in this video you understood what is cache memory and what is the significance of cache memory. Thank you.